Two Komatsu 575 Superdozers advance methodically across the Stockton mine, each handling 160 tons of material per pass. Operators monitor blade angles and engine output to maintain uniformity as the 30-meter-wide road takes shape. Coordination between the drivers ensures that the pushed material remains evenly distributed, preventing dips or ridges that could affect stability. Hydraulic systems adjust continuously to respond to uneven terrain, keeping the dozers level under immense load. Observing how the machines manage such weight highlights the engineering behind heavy earth-moving equipment. Each pass improves the road's grade while minimizing fuel use and mechanical strain. Crew members communicate constantly, fine-tuning speed and alignment for optimal efficiency. The combination of human skill and Komatsu engineering creates an effective workflow.
At first glance, the site may look like bare ground, but the construction of a diaphragm wall is about to reshape it into a foundation of strength. Each stage contributes to creating a structure that supports underground works with reliability and endurance. The atmosphere around such projects often feels like watching determination poured directly into the earth. The process begins with boring. Using heavy drilling rigs, trenches are excavated in the soil to the required depth and width. Bentonite slurry is circulated during this stage to keep the trench stable and prevent collapse. The depth achieved here determines the wall's capacity, making it a critical foundation task. Observers often find this stage fascinating because it reveals how deep engineering can literally carve through earth. Next comes reinforcement. Steel cages are fabricated and lowered into the slurry-filled trench. These cages give the diaphragm wall its strength and ability to withstand external pressure. The alignment and proper positioning of reinforcement are essential to ensure structural stability. It is striking how raw steel transforms into a crucial backbone once it is submerged underground. The accuracy of placement here can decide how well the wall will perform decades into the future. After that, stop ends are installed. These temporary elements control the casting of adjacent panels and define the joints between them. By doing so, the wall gains continuity across its length, ensuring no weak spots remain. Even temporary components carry significant importance in shaping the final wall. Without this stage, the structure could face uneven loads and reduced durability. Finally comes concreting. Tremie pipes are lowered, and concrete is poured from the bottom upward, displacing the slurry. This step solidifies the wall, permanently locking in reinforcement and geometry. The removal of slurry completes the transformation, leaving behind a solid underground barrier. Just as the sun glints off Cairo's early morning skyline, a network of bridges begins to reshape the city's landscape. Day after day, columns rise and spans connect neighborhoods once separated by traffic and distance. At Gesser el Suez, progress becomes visible almost overnight. A 4-lane, 560-meter crossing, expanding to 15.8 meters wide in just 3 months. Crews work in rhythm, pouring concrete, lifting steel, and setting barriers with a quiet determination. When the framework is complete, workers install safety rails, preparing for the first flow of morning commuters. The Joseph Tito Bridge is another sign of transformation. At 1,500 meters long and 12 meters wide, each beam and scaffold brings 2 districts closer. Under the relentless sun, every section is measured, hoisted, and secured until the bridge takes shape, an artery for thousands, built in only 3 months. At Badrashin, the horizon shifts once more. A 10-lane crossing, 100 meters long, and an incredible 43 meters wide, rising in just 5 months. Concrete trucks line the site, rebar bends into massive cages, and every pour adds momentum. It's almost surreal to watch space and steel turn into a living route. The Shubra Banha overpass, 1,050 meters long and 4 lanes wide, is finished in 5 months, standing as a symbol of what coordinated effort can achieve, with £205 million invested. Every new bridge opens a path for dreams, growth, and change. There's power in seeing a city evolve before your eyes. These bridges aren't just roads, they're new beginnings for everyone who crosses them. The construction of precast concrete road slabs begins with a system designed for efficiency and durability. At the start, the cable launching machine moves along the production track, laying out pre-stressed cables that will reinforce each slab. These cables provide the strength required to handle heavy loads once installed. It is remarkable to observe how such preparation forms the foundation of structural endurance. Transversal separators are positioned to define the slab length, ensuring consistency. At the opposite end, a hydraulic tensioning device secures the cables. This tensioning process locks the reinforcement in place, allowing the next steps to proceed. Every movement here shows the balance between mechanical force and controlled engineering. The automatic concrete distributor is then placed over the track. Fresh concrete is poured into the distributor, which spreads the material quickly and evenly. The speed of this distribution highlights the capability of the machine. Next, another automatic machine advances with vibrating screeds and a roller. The vibration compacts the concrete thoroughly, while the roller leaves surface marks for grip. The compacting stage feels like the moment the slab gains its real substance. Side molds are released, and relaxation cylinders gradually detension the cables. This controlled release avoids sudden stress on the structure. Finally, cables are cut, separators are moved, and the finished slabs are lifted for storage. Each finished slab stands as proof of engineering accuracy and reliability. At Gamuda Garden in Rawang, the site of a massive beam launch reveals both engineering strength and orderly execution. A girder system is prepared to handle a beam measuring 63 meters and weighing 114 tons. The sheer scale of this setup makes the process captivating to observe. The sequence begins with positioning the girder across the piers, creating a stable support for the upcoming transfer. The beam is then slowly lifted, guided into place with precision instruments and skilled coordination. Every movement carries weight, not just in tons, but in responsibility. As the beam slides forward along the girder, rollers and hydraulic controls ensure a smooth transition. The structure steadily reaches its alignment across the span. The patience required here is as remarkable as the machinery itself. Final adjustments secure the beam onto bearings, completing another step in extending the viaduct. In that moment, steel and engineering blend into enduring infrastructure.
What does it take to assemble a high-speed railway bridge across the Mangyong River? The answer lies in the precast span method. Each span measures 25 meters, with box girders manufactured in a controlled factory setting before being transported to the site. The sight of these enormous girders being prepared leaves a strong impression of scale and engineering power. The first step occurs inside the factory, where reinforced concrete is cast into box girder molds. Next comes transportation. Special trailers and heavy carriers move the 25-meter elements from factory to construction point. Logistics planning guarantees safety along narrow roads and bridge approaches. One can sense the challenge as convoys bring immense girders through local routes. Then comes the erection phase using the balanced cantilever method. On top of each pier, a launching gantry is installed. This massive structure extends outward on both sides, lifting and placing one 25-meter box girder at a time. The spans are connected symmetrically from each pier, gradually stretching toward the river's center. When the two advancing sections finally meet at the middle joint, they are locked together to complete a continuous span. Finally, specialized launching equipment ensures precise alignment and final fastening. This method reduces the need for scaffolding in the river, minimizing environmental impact.
Across Lingbing Channel, an extraordinary engineering effort shaped the Hong Kong-Zhuhai Macau Bridge, the world's longest sea crossing. The scale alone sparks admiration, with each part contributing to a structure spanning 55 kilometers. Construction began with prefabricated components produced on controlled production lines. These included the iconic towers, each over 100 meters tall, representing cultural symbols such as sail, dolphin, and Chinese knot. The symbolism woven into these massive towers adds a striking human touch to the technical achievement. Next came the undersea tunnel, stretching 6.7 kilometers. In just 53 months, 33 tunnel segments were precast, each measuring 180 meters and weighing 80,000 tons. The fact that none of them showed cracks highlights the effectiveness of the production process. Once completed, they were lowered into position beneath the seabed and aligned with an error margin of only 1.5 centimeters. Artificial islands were built to link the tunnel with the bridge, ensuring smooth transitions. Finally, the main structure stood ready, officially opening after years of dedicated work. Such coordination feels like witnessing determination carved into steel and concrete. At the edge of the Red Sea, the construction of Safaga Seaport is reshaping the shoreline into a gateway for global trade. The project stands out for its scale and engineering complexity, creating a multi-purpose terminal designed to handle diverse operations. Each shot in the video makes the enormity of the task even more striking. Work begins with the placement of massive concrete blocks. These blocks form the key wall, providing strength against waves and constant pressure. Behind the wall, backfilling progresses steadily. Layer upon layer of material is deposited to reclaim land from the sea, building the platform where future port activities will unfold. The gradual rise of solid ground over open water feels like watching the landscape being rewritten. Site preparation follows, with compaction equipment stabilizing the surface. Crews apply different paving layers, ensuring durability for heavy cargo and machinery. Every step adds visible stability, turning loose ground into a dependable foundation. The finished terminal will reach 1,000 meters in length and 17 meters in depth. This scale emphasizes its capacity for international shipping. One cannot help but anticipate how transformative the port will be once fully operational.
Stützbalken
Feel the force of
effiziente
precision
Übertragung
as
von
the smart
Stößen des
13
LKWs
VAR
auf den
automatic
Fertiger.
stirrup bender shapes steel bars up to 13
Zeigt die
millimeters in
orangefarbene
diameter with
Pfeilspitze nach
exacting
oben,
control.
ist das das Signal zum
The
Heben der
barcode
Mulde.
reader loads processing programs guiding
Zeigt die
each bend to
orangefarbene
meet strict
Pfeilspitze nach unten,
specifications.
soll die Mulde gesenkt werden.
Prearranged positions
Der nach
adjust
oben
for different
gerichtete
bar
grüne
sizes,
Pfeil
while
signalisiert,
digital electric
alles
servo
klar
motors
zum
deliver
Abfahren.
consistent, accurate bending. Waste is minimized as
Der
the machine
Paved Assistant
optimizes bar
ermöglicht eine
usage, and
unkomplizierte und
single
sichere
direction
Übergabe des
operation
Mischgutes
efficiently
vom
produces
LKW an den
stirrups and
Fertiger.
cut-to-size bars.
Durch
Even
das
for double
einfache
10
und klare
bars.
Ampelsystem kann der
Mobility
Lastwagenfahrer
ensures
die
it can be
Signale des
positioned directly on any
Fertigerfahrers
job
sofort
site,
verstehen
supporting
und
flexible
direkt
assembly.
umsetzen.
Watching operator and
Ein
machine
einziger
work
Blick auf
together
die rechts und
highlights
links
the
am Dach
streamlined
gut sichtbaren
workflow achieved
Ampeln
through
und
automation.
alles ist klar.
Productivity and
Kein Wunder,
precision
dass die
are on
Beschickungen
full
auf der
display,
Baustelle
end to
so
end.
zügig und unterbrechungsfrei abliefen. Unschlagbar auch das neue Bediensystem Ergo Plus 3. Verbessert und um hilfreiche Zusatzfunktionen erweitert, erleichtert es die Arbeit der Mannschaft erheblich. Neben dem kontrastreichen Farbdisplay schätzten die Bohlenbediener speziell das neue Smart Wheel auf ihren Konsolen. Mit dem griffigen Drehregler lässt sich die Bohlenbreite in 2 Geschwindigkeiten stufenlos und absolut präzise einstellen. Auch die Förderleistung der Verteilerschnecke kann von der Bohlenbedienkonsole aus ganz einfach gesteuert werden. Last but not least gehört die bequeme hydraulische Dachprofilverstellung über die Bohlenbedienkonsole nun zur Standardausstattung der Strich-3-Fertiger. Der Super 1800-3 verfügt über ein hochmodernes Antriebskonzept. Dank des Vögele Eco Plus Paketes werden eine signifikante Verminderung des Kraftstoffverbrauchs von bis zu 25% und eine erhebliche Reduzierung der Schallemissionen erreicht. Diese und andere technische Innovationen wie kürzere Aufheizzeit und verbesserte Einbauqualität durch optimierte Tampergeometrie überzeugten das Einbauteam ebenso wie die leichte Bedienung der hydraulischen Seitenschilder, der bequemere Aufstieg zur Bedienplattform durch niedrigere Stufen, die zusätzliche hochklappbare Aufstiegsstufe und der tiefere Laufsteg. Vieles ist einfacher und sicherer geworden. Die Einbaumannschaft war nach getaner Arbeit begeistert. Dass Vögele immer an die Mannschaft denkt, ist einfach klasse. Ihr Resümee? Mit dem neuen Super 1800-3i baut man einfach komfortabler, schneller und besser ein.
Quarries reveal how raw stone is transformed into building material through heavy machinery and structured processes. It begins with excavation and preparation. An excavator clears the surface and positions rocks into the cut lines. These stones act as wedges, channeling force along fractures in the granite wall. Workers assist by guiding the excavator's bucket into the right spots. The teamwork between human direction and heavy machinery is striking here. Next comes separation. With pressure applied, the inserted stones help push the granite mass away from its base. The block begins to loosen, revealing clean surfaces along the cut. Excavators continue working along the line, making sure the block detaches evenly. By removing surrounding debris, the machines open space for the block to be maneuvered. Watching such heavy stone shift gradually feels intense yet controlled. The sound of the rock splitting echoes across the site, signaling a successful break. Cutting follows with diamond wire saws. Steel cables coated with industrial diamonds slice through granite, extending the fracture and shaping the block. Water cools the wire and reduces dust, allowing continuous operation. It is striking how rough stone gradually becomes a refined surface ready for architecture. Finally comes transport. Front loaders lift the separated blocks, each weighing several tons, and carry them to waiting trucks. Operators balance the load with precision to prevent tipping. The trucks haul granite to processing plants, where cutting and polishing refine it further. The journey of stone from quarry to industry is both raw and fascinating.
The QST3000D chainsaw machine, mounted on the backhoe arm, powers through thick concrete slabs and dense forestry obstacles alike. Operators align the equipment with careful precision, ensuring each cut penetrates fully. Observing the coordination between hydraulic controls and cutting rotation is striking. The chainsaw engages, slicing cleanly through reinforced concrete and timber, while the backhoe maintains balance. Debris scatters as precise angles are achieved for every cut. The mix of raw force and controlled motion is thrilling. Safety checks are continuously observed, and adjustments are made for consistent performance. Operator and machine work in seamless sync, showing unmatched cutting power. Strength, efficiency, and reliability converge in this demanding task. At a single Carrara marble monolith, measuring 10.5 by 2.45 by 1.8 meters, is carefully transported across the workshop. Cranes and specialized lifting equipment guide its movement. Operators adjust supports to maintain balance, ensuring the stone's immense weight is managed safely during every precise repositioning. Hen.
Atlas Concrete's slip-forming machine shapes a continuous median barrier along the parkway. Wet concrete is fed into the slipformer, which molds the barrier's variable height as it moves. Vibrators ensure compaction, while operators monitor surface finish and alignment for consistency. The Nairobi Expressway transforms city travel with its elevated dual carriageway. Construction involves massive earthworks, bridge building, and advanced pavement laying. Interchanges are constructed at key junctions, allowing efficient entry and exit. Toll booths use both electronic and manual payment systems. Each section is tested for structural integrity before opening, promising to cut travel time through Nairobi from 2 hours to just 20 minutes. It's a milestone in Kenya's modern infrastructure. When a city like Zurich decides it's time to revamp its infrastructure, every step counts, especially in a project as demanding as the Ramy Strasa track demolition. Powerful machines line up along the stretch, each ready for a specific task. The operation depends on a coordinated fleet. Hitachi ZX670 handles the heavy lifting, Komatsu PC210 preps and moves debris, while both Liebherr A918 and its compact sibling work with precision in narrow urban spaces. Takeuchi TB295 lends its strength for those tight corners, making sure no section is left behind. It's truly impressive to see such a diverse range of machines operating in perfect harmony. The demolition starts by unclamping the old rails and carefully removing them from the sleepers. Workers and operators maintain tight communication, as safety is the top priority at every phase. Watching the team navigate these constraints while keeping everything on schedule is seriously inspiring. Concrete sleepers and supporting structures are extracted methodically, stacked for disposal, and sorted for recycling. Even in the heart of the city, the team works to ensure the surrounding area remains undisturbed. Trucks and loaders transport debris away efficiently, clearing the site for what's next. With rails and sleepers gone, the entire area undergoes detailed cleaning. Sweepers and smaller equipment ensure not a single fragment is left behind. What stands out is the care given to every detail, from material handling to environmental protection. Special disposal procedures are followed, meeting strict Swiss regulations for urban construction. Projects like this don't just clear a path, They set the stage for modern infrastructure. The effort on Ramy Strasa isn't just about demolition. It's about preparing Zurich for a new era, with speed, safety, and impressive technical finesse. Standing at the site, you can really sense the pride behind every move. Nothing grabs your attention quite like a futuristic geodesic dome taking shape from bare ground. Construction kicks off as workers in heavy equipment position large precast concrete blocks around the build site. The loader operator carefully places each block, using the machine's articulated arm to ensure tight fits and proper alignment. The coordination between ground crew and operator is essential. One wrong move, and the whole process could be thrown off. As the base layers take shape, more blocks are methodically stacked, forming a stable foundation for the dome. Workers move along the growing structure, double-checking every position for accuracy. Seeing the blocks locked together like a giant puzzle is oddly satisfying. The structure grows higher as more blocks are added, creating a wall that begins to curve inward. For the upper layers, a loader equipped with a crane attachment carefully lifts and positions each heavy block. It's incredible to see such precision with massive materials. Ladders are set against the dome to allow workers to guide blocks into place and secure them. The dome gradually closes, with the last few blocks requiring extra attention for a perfect fit. Every block plays a crucial role in the overall strength of the structure. The teamwork and attention to detail on display highlight just how challenging and rewarding large-scale concrete construction can be. When the final block is set, there's a real sense of accomplishment. Concrete construction kicks off as fresh mix pours across the rebar grid. Workers jump in, quickly spreading the heavy concrete with rakes and shovels to reach every corner. The surface gets a thorough shake with a concrete vibrator, forcing out trapped air and making the slab more durable. Next up, a screed machine glides over the wet layer, leveling it perfectly and setting the foundation for a smooth finish. Roller tools follow, pulling the top flat and getting rid of rough patches. If needed, a dry shake hardener is spread evenly across the surface, boosting strength and adding color. As the slab sets, power trowels roar to life, spinning across the concrete to polish and harden it into a flawless floor. A long straight edge is then used by hand to refine. Finally, a steel trowel smooths out any tricky corners. Every step is checked and adjusted to guarantee a top-notch result that's ready for anything the job site throws at it.